Um, so today we'll talk about how to train and distill large language models using Amazon SageMaker. With me, I also have Yaniv, who's going to join me shortly after I make some introduction about Amazon SageMaker pipelines to you all. And he's going to talk about how his organization, AI71, has used SageMaker pipeline to move the applications and automate the flow in production. Let's set some stage on why we're really talking about SageMaker pipelines, why we're talking about automating the workflows to move to production. As per a recent survey that's towards the end of 2024 from one of the analysts, we have a report that talks about how the spend has grown exponentially year on year into generative AI. We're talking from $7 million to $18 million investment in generative AI. We're also talking about how the customers are choosing multiple models and how they're choosing multimodal models to achieve what they want in their businesses through generative AI. And also the survey talks about how customers are picking the open source, open weight models to customize versus just accept as is, right? So we're talking more and more customization, more choice that's available to the customers, and hence the need to talk about how we can automate these workflows, right? How we can move the experiments into productions and what is the right way to do this. We'll talk about some of the challenges and how we overcome these challenges using Amazon SageMaker. I'm Tasneem. I'm Senior Solutions Architect with AWS. And today I'll talk to you about the ML Ops. We'll talk about how ML Ops is evolving into FM Ops, Generative Ops, and how we're using SageMaker to address these challenges. Let's talk about governance. Anybody, show of hands, who are from DevOps here? All right. Anybody here from this side on DevOps? Okay, so one or two hands that I've seen. So we know that governance is at the core of any DevOps automation, right? And it becomes even more essential when you talk about machine learning governance. You've got a lot of data involved. You've got models that are open source. You've got models that are open weight, and then you need to govern them all the most to make sure that what you're bringing into your organization and what you're promoting to production environments is secure and governed. On top of MLOps is the introduction of FMOps, because while we were still training the models, while we're still looking at the algorithms the models are running, now with the introduction of foundation models, we need to have a governance of how the open source models interact with your own systems, right? And how the generative AI project lifecycle builds upon this. And a reason why we're talking about generative ops is that once you have your FMs, once you have your ML in place, you need to have very secure sources and the secure way of talking to your applications. Generative AI ops sits on top of all of these layers to ensure that it is most secure interacting with your applications, and the workflow that you want to create to move your generative AI applications to production has to be governed, has to be secure, has to be easy, simple, and has to cause you less cost. All right. Let's move ahead. Look at some of the key challenges and some of the actionable items that we'll talk today with Amazon SageMaker, right? So while creating path for generative AI applications, I know that there are a lot of challenges, but I'm probably going to talk about 6 to 8 of them. And the reason why we're talking about these is because it makes sense to build them in a workflow. But there are, of course, a lot of interrelated challenges which need a lot of deep dive. So we'll keep it at a high level today. The first challenge that comes with machine learning or with generative AI is we know that it's data, right? Collecting the data, labeling the data, bringing in human in loop to annotate the data, to validate the data. It's not an easy task, right? Particularly when you talk about FMs, the amount of data, the amount of parameters that we're talking is really huge. So with SageMaker, SageMaker Data Wrangler, we help you to fine-tune your data, to label your data, and use it in your fine-tuning, either in supervised learning or in reinforcement learning. So SageMaker Data Wrangler supports you in data labeling and annotation with human in loop to ensure that all your data is correctly annotated. All right. So the next challenge after you have had your data in place is when you start experimenting with models, right? Now, we all know that there is, right in the previous session, you saw our colleague spoke about the n number of models that are available in SageMaker and Bedrock. But apart from that, if you want to build if you're bringing in your own models and porting them in and working on them, you're not just using one model and finalizing it, but you experiment with multiple models, with multiple evaluation metrics, and then you make a decision on what is it that works best for your business use case. Once validated, you move it or promote it to higher environments. But again, there is a challenge, right? Let's talk about this workflow. We were talking about fine-tuning a model, right? Choosing a model, processing the data, the evaluation metrics, the parameters. All of this define, and then you need to checklist each one of these against every model that you have experimented. How can you really overcome this challenge of manually maintaining this is by using the integration that we have in place with MLflow, and also using the SageMaker model registry. So what it does for you is that you define a model and you define your experiment with the criteria for the evaluation metrics, and the model registry has a database of all of these experiments, and then you define basis what you want to promote it automatically into a higher environment. And of course, you can use multiple services to port it into production. Let's move to prompt management. Now that you have your data in place, you have your model experiments, and now you need to be talking to your Gen AI applications, and prompt management becomes all the more important. So how do we really do the prompt management? It's not just about writing prompts or managing the prompts. It's also about having a strategy on how you want to manage it. Let me introduce you to prompt engineering using Bedrock, right? Where you have access to the models through an API, or if you want to go the more traditional way, where you say, you know what, we want really the entire model to be available, and we want to think of customizations through our own metrics, through our own criteria, and then you have SageMaker Jumpstart, through which you can access the models and start writing your own prompts. There are prompts available, prompt strategies available for most of the models that are available, and you can start working from those. All right. So prompt management, doing prompt management through Bedrock offers you reduced cost, increased reliability and traceability, and also increases agility and collaborating with multiple developers who are working on these. Let's move to the next one, which is the most important thing in the flow, that all these pieces, how are you going to orchestrate all of these pieces together, is by using the Amazon SageMaker pipeline. Now, Amazon SageMaker pipeline is a UI-based task, UI-based pipeline, where you can drag and drop the activities that you want in your pipeline. Right from orchestration to an event at which you want to invoke an action in the pipeline, making it really very easy for the administrators to manage it, and it quickly converts your code into the pipeline It helps you in caching, and most importantly, it's event-driven and it is serverless, which means you trigger the infrastructure for your required pipeline only when needed. In a particular event, for instance, there's a change in production data, and you want to trigger the pipeline to rerun a particular evaluation metrics, and then you have the infrastructure used only when the event is triggered. Evaluation and monitoring. Now, we build the pipeline, evaluating and monitoring not just the models, but also the agents is important. Quickly run you through on how we do that. Evaluating and monitoring is multifaceted, right? It is not just dependent on one parameter. It depends on the model you're choosing, depends on the type of data you got, depends on the feedback that's coming in from your users, from the human feedback that you have, multiple sources for feedback, and how you want to manage this with your agents and applications, and how you can manage it through the system, through multiple environments. Now, all of those can be dealt using SageMaker Clarify and SageMaker MLflow. Now, these two services go hand in hand. They support you in multiple factors on evaluating and monitoring your agents and your models, right? Agent evaluation, apart from the ones that's available with the tools that I just mentioned, you could also use any open source tools that are available and evaluate your own agents. And of course, we've got a gamut of monitoring solutions that are available within AWS that help you to monitor and observe the performance of your agents, the performance of your infrastructure on which these agents are running. So once we've done all of this, we've evaluated the agents, we've created a pipeline, and now we need to look at the reliability and governance. Hence, talking about model registry again, where you feed all the information and you govern how these models have been evaluated and what was done in past and how can things be improved in future. So once that is done, implementing safeguards. Now, I would like to remind you that we are talking about safeguards from a RAG point of view, from securing it from prompt injections, securing your generative AI applications from not giving out unfiltered content or content that is offensive. So we will be using guardrails on Bedrock to filter out these prompts as and when your generative AI applications are talking. Please be reminded, when we're talking about generative AI applications, the challenges that we're talking are very specific to generative AI ops, but there are underlying layers where security, encryption are really important, and that's another topic that has to be dived deep into in a session of its own. So once that is done, and also securing the endpoints or the inference endpoints using SageMaker by allowing the right content, the right type of the model that you want to expose into the endpoint to make sure that your resources are optimized and also keep it secure. Last but not the least, when we talk about resource optimization, when we talk about these challenges, cost really stands up, right? I mean, show of hands, those who are really concerned about cost when training the models and moving them into production. Absolutely, everyone out there, right? So how do we really optimize the cost? Choosing the right models, choosing the right methodologies on how to fine-tune or customize your models. LoRa is one of the techniques through which you can just train a layer of the model that is more important to you to customize to a particular domain. You could start with using the right type of compute instances, for example, AWS Trainium to train your models that has better performance, that has better cost performance as well, and using instances as and when required and keeping it managed, so you could save more on the cost as well. The reason why I have spoken about the end-to-end SageMaker pipeline and automation and move to production is because our customer, Yaniv, from AI71, now will talk about how their organization has used SageMaker pipelines to move their applications, to distill the agents and move them into production. Yaniv, may I call you, please?
Thank you.
Welcome.
Hey everyone, so thanks for staying. So I'm part of AS71, which is a newly formed company in the UAE. We exist for about a year. Tell you a little bit about ourselves before I'll move to the talk itself. We were mentioned, by the way, at the main talk earlier today as new partners of AWS, something relatively new. So what we are is an applied AI team. We develop solutions around LLM, generative AIs, and mainly agentic flows. We have a pretty wide portfolio. We are right now we are mainly focusing on enterprising, but we are also building a platform for developers that we hope that will be out in a few months. It's still in the making. And we also have an advisory team that helps companies build and design their own AI solutions. The main differentiations and what makes us different, because as I'm guessing all of you know, this market is pretty much flooded and there are a zillion companies around it. Few things. First of all is the people. We really target top talents from around the world. We were able to pull people from Google, AWS, Microsoft, and also from many startups. We have a really amazing team and we're really proud of it. Another thing is the second differentiation we have is also people. We have very strong collaborations around the world with many research groups that help us make sure that we always have cutting-edge technology when we're leading the industry and not being led. And the third one, which is just as important, data. We have a lot of access to data from different types from the region, and we use it very wisely to make sure that our models are really, really, really good. So what do we offer? Our main offer is called S71, which is a platform for enterprises to build their own chatbots, or we build it for them. We will become self-served eventually. Right now we have a team of custom solution engineers that work with our customers and make sure that the bug system they want behave exactly as they expect. We have a lot of different connectors. We do everything from HR to web search. And we also have a lot of agentic flows to allow companies to operate and do complex operations with us and automate flows. And we have the platform, which is a bit premature right now, but it's also in the making, which will allow developers to build their own solution around RAG, LLM, and agents. In addition, we also target a lot of different industries like construction, health and education. There's a few more that are not here when we're building customized solutions for these industries. Okay. So after the long intro, let's move to why we're all here and let's talk about agents. So first of all, what are agentic flows? So I'm sure all of us know what LLMs are and chat. And the main issue is that there are a gap between what we want to do with the LLMs and what the LLMs are actually capable of doing. Mainly when it goes to complex solutions or complex tasks, the more complex the task is, the highest the chance that it will fail. So the idea about agent is instead of doing one complex action, which may fail or just not return what we expect, we decompose it into much smaller one. Each one is much, much simpler. And using that, we can increase the chances of the operation being done correctly. So that's exactly what agents do. Instead of one huge and complex system, we have a lot of smaller ones that perform the same action eventually. Each of it takes a different component. At the end of the day, we increase the chances of getting the right answer, reduce the chances of hallucination, and improve the accuracy of the system. So how does agentic flows improve the flow, the reasoning, and the accuracy? The general flow, which again is very, very general, it's got nothing to do with AI71, is we have the first component which does the planning, another one that retrieves the information, third one that analyzes, and an act. And this goes in cycles. These cycles can be very, very dynamic, and they can be very simplistic. For example, we can have an agentic flow that starts from a general user request. Please get me a vacation in Kenya. plan it for me. I need to do it in these dates, and tell me if I have enough vacation dates. So what will eventually happen, the first, we'll have a planner agent at the start that decompose this into a lot of smaller tasks, web search, collect information, connect to Salesforce or whatever HR database they are using, check for the vacation days, summarize all the information, and build a report for the users. If you would have done this with one call with an LLM, it might have worked, likely no. Most likely what the user would get was a partial answer, hallucinations, and so on. But when we decompose it into smaller actions, we make sure that we increase the probability that the response is accurate and grounded in actual information. So, the title of this talk was about distilling. So why do we need to distill models? One of the main issues with LLM is pricing and latency and throughput. While large LLMs are magnificent, they can do amazing things and they can do it very accurately, they are very slow and they cost a lot of money and computation. So what can effectively happen, the flow that I just described to you, if we would have done it with large general purpose LLMs, it could easily take up to 10, 20, or maybe even 30 or 40 seconds. And this is not a very good user experience. What happens is that the user gets annoyed, it gets distracted. Most users, after such long time, lose context, and we don't want to get there. So the idea in distilling is, let's take a very large general purpose model and replace it with one small model that can only do one action. So while the large model in general can do much more things, we don't need it for the agent for all these things. We just need a single operation that can be very, very simple. So we replace the model with a smaller one, and that mimics the behavior of the larger model just for this specific task. It will obviously be performing extremely badly on general tasks, but for this specific task, it can easily be better than the general purpose one. So just as an example, it's not a straightforward approach. There's a lot of art in it. It's not like we can just take any task and replace it with the smaller models. Many of the tasks require very long context, requires very high-level reasoning, complex reasoning, and they cannot be replaced with smaller models. So just for example, if we just want to detect what the user wants to do, like I explained earlier, understand if the user wants to do a web search, or the user wants to search on its own knowledge base, or maybe something else. That type of task is very good for small model, because at the end of the day, in most real-world solutions, we are limited to a finite number of actions the user want to do. And that allows us to use small model and just train it on this type of actions. Another example is to generate summary, which again, small model can do very well because it receives tokens, it just needs to summarize them, replace them, and it's not very complex. On the other hand, if we ask the model to suggest a full reply, read the whole document, understand it, create semantic relations, understand each paragraph separately, understand the context of the whole document, and then reply, this is a very complex action, and a small model will likely do very, very badly at it. As a rule of thumb, the longer the context is, meaning the more actions, the more things the model needs to be done, the higher the chance that a small model cannot do that. Okay, so now we understand why we need agents, and we understand why we need to distill models. Let's talk about how we actually do that. So the general pipeline that we have, if we look at it in terms of bullet points and components, it's very standard. Meaning if you're going to go to a talk by a completely different company, they're probably going to have the same bullet points. But when we go into the details, that's where things start to be interesting. The first step is to collect data. Again, we want to make the small model behave like the large ones. So the first thing we are doing is just run the large model on a lot of data. We prefer this data to be real-world data. We learned that it's actually better to use smaller samples that are really, really good and larger samples that are synthetic and not that good. We need to have a strong seed at the core of the data. And we collect the responses of the model. In the next step, we clean the data. We use another model, which is a judge model, that just checks the replies of the previous model and tags any replies or any responses that might be problematic, because we want the accuracy to be at least as good as the previous model, but if we train on the errors, we will never reach the same accuracy. Because training obviously is not perfect, otherwise we'll be overfitted. We can only get to some extent to be as accurate as the data set, and we want to generalize, so we need to make sure we clean it. Next step is the distillation and the fine-tuning, which I'll talk about in 2 minutes, but we just used SageMaker for it. We really, really like SageMaker, because as you'll see in a minute, it makes these slides really, really short. There's not smart actions we need to do. It's pretty much off the shelf. Next step, which is extremely critical, is the evaluation of the model. We use another model, another judging model that has to be different than the original model, because we don't want to be overfitted in order to decide how good the model is. So far, we have at least 3 large models. One, which is the foundation model, the model we distill. Second, to be the judge for the training. And the third one, to be the judge for the data set, for the test set. And they have to be different. Again, otherwise, you can be overfitted without even noticing. And the last round, which is extremely critical, is to continue collecting responses from the small model after it's deployed and make sure it's improved in an ongoing manner. So now let's start to dive into the steps one by one. So we start with the data collection. First step is very straightforward. We just run the model on real environments with our design partners. We let the users use our model. They, of course, know that we collect the responses. And we collect both what the user typed and what it got in return. Okay. The next step is the data validation and cleaning. And this is, again, extremely critical step. Now, here there's a really interesting trade-off between how good the cleaning is to how fast and how cheap we can do it. And obviously, we're a commercial company, so we need to make money at the end of the day. Ideally, we would just take a lot of highly skilled people. They would analyze the data set, go line by line, check the responses of the model, and fix it or tag whenever there's a problem. But obviously, we cannot really do that because we're talking about a lot of data. So we're trying to balance from the data between that approach to the cheaper approach, where you just run another judge model and let it do it. What we are doing currently is doing, first of all, a manual random sampling of the data, just to see that it makes sense, the data is more or less okay. Then we run the judging model, and we look for 3 responses. 1, are you sure the data is bad? Are you sure the data is good? Or 3, unsure. And we learned that if you give these models, these 3 options, the outputs are actually much better. If you try to force it to be a binary response, in many cases, it made the mistakes, but this case, we get a lot of cases in the middle, which are, it's more important for us to have knowledge of what is right and what is wrong than what is the actual quality of the original data. Then we have manual users analyzing all the data that is tagged as marginal, and then they decide what to do. They usually just fix the label on their own. And the bad ones, it depends on the volume. If there's a lot of them, we just don't use them. And if there's not a lot of them, or at least we have the manpower to analyze, then we replace some of them with manual work. We are also working on automating this process, but so far, while, again, a lot of LLMs are really, really good, it doesn't take us to the quality that we expect to get. Okay. The next step is just to make sure that the data set makes sense, no discrepancies. The probability of the data is what we expect in terms of real world. We don't want the data to be overfitted to specific use cases. And finally, we're going to the training, which I'll talk about in a minute. Okay. So if we look at the schema of how does the training looks like, in Amazon SageMaker, it's actually quite simple, mainly because it's something a lot of people are doing, so the one-size-fits-all actually does fit all in this case. What we need to prepare is, first of all, the external storage that holds all the data, and we store it on an S3 bucket. We need a checkpoint in the middle just to make sure that this is where the output model will be deployed to. We have the training script and the Docker container, which contains the foundation model that will be trained. It's important to note that at this point, the large model is out of the picture. We now have the model's responses and the data to train on and the small model, and we don't need the model anymore. When we go to code, as you can see, it's really, really, really simple. We just have 3 calls to initialize instances for the container, for the model and the fit. And again, this is just this is why we like SageMaker so much, because if I would have done that on my own, it would have been a much more complex code, and this talk would have looked much different. I think this code is really readable. I mean, I can go line by line, but I think it's very easy to understand what each line is doing. So again, the first one, we just get the data. Second one, we just inject it to the model. First one, we just do the fit, which does the actual training. Okay. So now that we finished training the model, we need to validate and need to deploy it. And again, it's really, really simple on SageMaker. We first of all initialize the model locally, and then we can create an API, and we call this model from different places. One of the main issues around the UE, this privacy is really critical here. There's a lot of governmental agencies, and we can't just use the model as is from AWS. So in many cases, we just deploy it or copy it, or just take it outside. And because it's a small model, it's quite an easy task to do. With large model, we cannot really do that. That's another reason why we don't distill large models, why we don't use large model when we don't have to. We initialize the predictor, and then we test. This code just demonstrates how we take the model outside and doing the test. The important thing is the inputs. I didn't mention it earlier, but we generate the test set a bit differently than the train set. The test set is only real world data. There's nothing synthetic here. The model is not involved. And if we can, we ask different users to generate it, because we want to make sure that we're not overfitted, and if there's a problem, we want to detect it. So in the evaluation stage, we just run the model on this data. That is, it has to be real-world data. One of the main issues we saw, by the way, is there's a lot of data leakage, and models, all the off-the-shelf models are very, very contaminated, meaning they saw a lot of samples from the data sets. All of the online data sets are probably have leaked to some extent to all the models. So our approach is to use our own data that is created by the users. In the next step, by the way, we are building a tool that can be used by external developers called Data Morgana that can generate this type of data for them based on either a seed or supplying documents and creating pairs of questions and response and this type of tasks. This is still under work, so it's not mature yet, but it will be out in about 2 to 3 months. After we validate the model and we are certain that it's good enough, we deploy it with the agent, and then we evaluate the whole flow. One of the main problems we have in this type of setups is that we're not just, the model is just one bolt out of the system. It's a very long process. A lot of things are happening. So we also need to evaluate the whole agentic flow. It's not enough to evaluate this specific model, but we also build an end-to-end evaluation system, which again will also be available for external users in a month or two. So follow our website on AI71. We'll announce its deployment. And we are building tools that allow to, first of all, evaluate the small model, making sure that it behaves the way it expected on the test data. And then we're making sure that the model actually improved the flow. Because we could have made a mistake, it can be possible, it actually happened to us many times, that it seems like the small model behaves really, really well, but when we plug it in to the whole flow, something gets broken. It can happen not just because the model is not good enough, but maybe the new model doesn't interact the way it should with the rest of the pipeline. In these cases, we need to decide what to do. Okay, so the last thing I'm going to talk about is the next things and the thing we are working on. One of the main things, the main work we are already doing is expanding the agent coverage. Right now we focus mainly on text-to-text, but we're already working on text-to-audio and audio-to-text. We have a few very good partnerships, and we hope to have really world-class products around that in very short time. We want to allow the users to ask our agents in just natural language, just connect to them, ask them, and receive the response in audio as well. Another thing we are working on is building an RL system to help agents of new types to learn. One of the main The main problem of having supervised learning is that it's very, very limited. In some cases, you need to give your models responses as they behave. So we're working on this pipeline as well. And the last thing I already mentioned, we're building a pipeline to improve the quality assurance of models. All of these tools will be available on our developer platform in a few months. Thanks everyone for listening, and no camels were harmed during the making of this presentation. Thank you.
Can you go to the next slide?
Sorry?
Next slide, yeah. Thank you, everyone. And we'd really encourage if you can fill in your feedback on the survey link that's provided in there. Please scan the barcode. Really appreciate your feedback. Have a good rest of the day, everyone. Bye.